All right, in this problem, we have L'Hopital's rule problem. We're given the limit as x approaches 0 from the right side of 5 cosecant x minus 1 over x. Okay, so in order to use L'Hopital's rule, first you have to prove that you're currently getting a limit of 0 over 0 or infinity over infinity. That's the only time that L'Hopital's rule works. Okay, so let's see what we have when we plug in here. So we plug in a 0 into cosecant, and if this helps, you can change it into sine. We may do that later in the problem anyway, so let me go ahead and do that. So 5 times 1 over sine for the cosecant minus 1 over x. Okay, so when you plug in a 0 into sine, you get 1. Okay, so you plug in a 0, that you get a 1, and you plug in a 0 here, and this is undefined. So that really doesn't help us too much in this problem. So we need to try to get this in the form that it is a 0, 0, or infinity or infinity. So let's combine these two fractions and see what happens. So if we find a common denominator, we have a sine x and an x. That means the common denominator is x sine x. So let's put those together. There's our 5 out front. So this one needs an x on top, and this one needs a sine on top. And our common denominator is x sine x. Okay? So that combined those two fractions. Let's see if we're of the form 0 over 0 or infinity over infinity, the indeterminate form. So we plug in a 0 here, and we get 0 minus 0, which is 0 on top. And on bottom, we get 0, well, the 0 times sine x. So that's definitely 0. So you do get 0 over 0. Okay, so that's one of the forms that it works in. So now that we've shown that it is an indeterminate form, we can use L'Hopital's rule. And what L'Hopital's rule says is that you take the derivative of a fraction that's in this form, but you have to take the derivative not with quotient rule, because this is a quotient, but not like that. We'll take the derivative of the top as if it's completely by itself. We'll call that f of x. And the derivative of the bottom, we'll call that g of x. So if you have the limit as x approaches, say, a of f of x over g of x, and that gives you either 0 over 0 or we also said infinity over infinity, then you can take this limit and it will give you the same answer. It will give you the correct answer to the limit. Okay, so the derivative of the top, the derivative of the bottom, redo the limit, and you'll get the correct answer to the limit. That's L'Hopital's rule. So again, not using quotient rule on this. That's a common mistake. We are taking the derivative separately from top to bottom. So when we do that, let's go ahead and write down the 5, since that's just a constant sitting out front. We're not going to mess with it. And then the derivative of x is 1. The derivative of negative sine is negative cosine. That takes care of the top. Now the bottom. This is product rule on bottom. Okay, so that's going to give us x cosine x plus sine x with product rule. Okay, now if we plug in a 0 again to see if we can get our limit, we plug in a 0 again and we get 1 minus, what is cosine of 0? 0. So, or 1 rather, sorry. So 1 minus 1 is 0. So we get 0 on the top in the numerator. And then down here, of course, the 0 plugged into the x gives us 0. So this whole term's gone. Okay. And then sine of x gives us 0 when we plug it in. So the bottom is going to be 0. So we still get the indeterminate form. Okay. So it didn't immediately help us to use L'Hopital's rule. But the good news is we can use it again. Okay. Because this rule holds true no matter how many derivatives of the top and bottom you take, so long as they keep giving you either 0 over 0 or infinity. So we can just take this derivative again and try again. So let's do that. So limit as x approaches 0 from the right of 5. Okay, the derivative of 1 is 0, so that's gone. The derivative of negative cosine is positive sine. So there's the top. We've got a quotient rule here. Okay, so first times the derivative of the second. So that's x times negative sine x. I'll put the negative out front. Okay. And then the second times the derivative of the first. Derivative of x is just 1. So it's plus cosine x. And then the derivative of this single term sine x over there is also cosine x. Okay. And you could clean that up a little if you wanted, and make that 2 cosine x if you wanted. And you could even bring the 5 in. Since there's only one term on top now, that should be fine. So let's do that. So 5 sine x over negative x sine x plus 2 cosine x. All right, let's see if L'Hopital's rule helped us now. So when we plug in a 0 into the x values here, so sine x is going to give us 0. Okay, so we get 0 on top, so things aren't looking so good so far. Let's see if the bottom also gives us 0, and we might have to try L'Hopital's again. So we plug in the 0. Of course, this term goes to 0, but cosine x of 0 is 1. So actually, the bottom, this one goes to 0. This term is 2. Okay, so 0 over 2 is an acceptable answer. That is 0. So the answer to this limit is 0.